Okay, let's get started. The basic creed of Chicago economics is Bellmanize. This is an imperative that urges us to be able to formalize any economic problem in the language of the Bellman equation. So in this short session, we are going to look into a problem in order to put the whole stuff into the language of the Bellman equation. So our first and foremost problem in this session is to write the Bellman equation, Bellman equations, because we are going to have more than one Bellman equation. Okay, this is a time allocation problem, which is about a student who is working on a problem set in MATLAB, and she must decide how much time to devote to working on the problem set and how much time, the remaining time, to devote to learning to increase her capital stock, which is regarded as knowledge. Please go over the details, and we are going to solve the problem right away. So let's solve the problem. As I've just mentioned, this is a time allocation problem. We can devote time to two purposes. One is production. We work on the problem set for higher grades. This is one purpose, and an alternative use of time is human capital accumulation. Okay, the variables. KT is human capital at period T. LT is the time share devoted to production. We are lining up the details. Okay, we have a progress function. These two variables go into a progress function which describes how the student performs in solving the problem set. Most importantly, this is a timeshare. LT is a timeshare, so it must be in this closed interval. And we have this is a law of motion for the grade. So in period T, the student has a certain stage. She is in a certain stage regarding her homework, and by her progress function, she can improve her performance in solving the problem set. And if she works on the problem set, her performance is going to improve. And we have another law of motion for the capital stock, her knowledge, which is described by this increasing production function. Please note that her progress function describes the change in grade. So this is the one period. This is her one period return function. Okay. So this is the function f, by which we measure her utility. Okay, so first of all, let's line up the state variables. State at t. This is kt, of course, the capital stock. pt, the current stage of the homework, and nt, the days remaining before submission is due. The control variable, control at t, is the time allocated to working on the problem set. What is the feasibility set? We have already covered this. So the time allocated to working on the problem set must be in this closed interval, or more formally, we can say that the feasibility set takes this shape. Okay, these are physical constraints. So the time allocated to working on the problem set cannot be lower than 0 and cannot be higher than 1. Okay, so these constraints are normal. So problem D, or part D. What is the Bellman equation of the student on the day of submission when on the day when the homework is due? At this point, we need to clarify some of the assumptions underlying the problem. So what do we need to assume? The student, let's say additional assumptions. The student works through 3 days on the problem set. Okay. Daily decision regarding L is made in the morning. And homework submission is due at the end of day 3. So these are the additional assumptions, and now we can graphically represent the problem. I promise it's going to be fine. This is day 1, day 2, and day 3. This is morning. This is evening. Here the project starts, and this is submission. Okay, value functions. 3 days to go, 2 days to go, and 1 day to go. So each value function summarizes the problem of the start of the day. Okay, and time, this is period 1, period 2, and period 3. Here N1 is 3 because the student has 3 whole days. The following day she has 2 whole days, and finally she has 1 day. Okay, capital stock in the morning of day 1 is given. Okay, and P1, it is also given, and these are the endogenous state variables. And this is the exogenous. Okay, because this is exogenous, because how time is passing by cannot be influenced by the decisions of the student. So, for instance, on day 1, we have the following. On the basis of her decision of allocating, this is not LT, this is L1, time L1 to capital formation, the student has K2 in the morning of day 2. Likewise, by allocating some time to learning in the following day, in the morning of the following day, her grade is going to be P2, and time follows its own law of motion. So we also assume that grading is fair. So her work entirely establishes her grade, her final grade. Okay, so what happens on the day of submission? The value function is V1 and the decision is L3, because we are, once again, we are in the morning of day 3, and in the morning of day 3, this is L1, okay, let me be more accurate. So decision L1, L2, and L3. Okay. So in the morning of day 3, this is the day of submission, we have the value function V1 and the decision L3. And initial value for the day is P3, and we have K3 as the endogenous state. Okay, so this is the value function of day 3. We are in the morning. 1 day to go, because we are in the morning again, so the student can devote her whole day to working on her homework. So we are going to maximize in terms of time allocation this function. And something. This is the problem after day 3. The question if it exists. How can we maximize V1? What is after the third period 3? Nothing. There is nothing after period 3 that is related to the project. So we can be sure that the student is not interested in increasing her capital stock in the final period. So this is another important additional assumption. Capital stock is useful only in this project work. In this project work. The student accumulates her capital stock in order to use her knowledge in the project work on the following day. So on the day of submission, the state is P3. So her final grade is going to be determined by this equation. Okay, so by knowing K3, the state, the student makes her decision regarding L3 in order to maximize P4. So, given that there is nothing after period 3, the problem of the day of submission can be summarized by this Bellman equation. Okay, this is given, and to decide. This is the control variable, decision variable. Given the fact that the student cannot use, or we assume that the student cannot use her knowledge outside this project, she can maximize the final outcome, the final grade of her project by devoting the whole day to the project work. And it implies that the final capital stock K4 is going to be K3, because we can assume that if we don't devote any time to learning, there is going to be no change in the capital stock. Okay. This is a dynamic problem. I'd like to emphasize it just to be on the safe side. This is a dynamic problem because daily human capital accumulation is such that capital helps, supports problem solving of the following day. And project work, most importantly, project work by itself, in itself, doesn't increase the capital stock. So the student, one day of the student looks like the student, on the basis of her current capital stock, works on the project, and some portion of the day she devotes some part of the day to learning in order to increase her capital stock, which she uses in problem solving the following day. So okay, this is all we know. This is true. Okay, and the final part of the problem, the initial Bellman equation, K1 and P1 are given, and she has 3 entire days. And the student is supposed to make a decision regarding the time to be allocated into project work. And this is the value function of the following day. And please remember, there is no discounting. So on the following day, she is going to have K2 as human capital, P2 as grade, and 2 days remaining. So taking the law of motions into account, we have the following Bellman equation for day 1. And now we are expanding the second half of the Bellman equation, because K2 comes from K1 and the production function of human capital, and the grade evolves according to its own law of motion, and 2 days to go. So this is the Bellman equation of the opening day of project work. So this is all for the day.